Hello everyone, Adam here. I have noticed that there's a lot of interest in the microphone suppressors, so you asked me in the emails whether I can provide some solution for you that would be cheaper and even simpler than the one that I have showed in my videos. So today I'm going to show you the cheapest and the simplest as you can construct. So you can see this one already on the screen. So it consists of the Arduino DigiSpark, which I like very much because it's cheap and it's easy to use it. Also there's a power amplification module, 2 times 3 watts, and we have sets of 10 ultrasonic 25 kHz transducers for each audio channel. So the best would be to use 20 of them, and that will give you in an outcome something like even up to 10 meters of the jamming range of the microphones. So where to buy all this stuff and what is the price? So let's start from the transducers. You can buy them from the AliExpress or Alibaba. 10 of them costs something like $12, as you can see. You can find them even cheaper, but something like 10 up to $15 per 10 of units. DigiSpark, it's officially not sold anymore, but you can buy them also from AliExpress for something like $2. And the power amplification module costs something like 10 cents per module, maybe 20 cents per module, so it's even cheaper. And let's get started. So the code looks like this, and I have used a randomized bias for the frequency. These random values from 0 to 10 were calculated using an Excel. So this is to modify the 25 kilohertz frequency with some steps, but the modification is as a random white noise, I would say. And then we modify the pulse width with this value. So we have some center frequency, which is 25 kilohertz, and then these values are added to this to achieve the random white noise. And this random white noise is actually visible on the microphone. I will show you this in a second. So let's go to see how it looks like and how it works when mounted.
Okay, I have it all connected. So here's the DigiSpark unit with USB from which it will be powered. So I have also a power bank to connect. And this DigiSpark is connected over 5V and GND line to the power amplification module to give necessary voltage to power this device. And then there's also connection, but only for single channel. In my case it is a right channel from port 0, which is a ground line for the audio input, and from P2, which is a signal line for the audio input, to right channel audio input right here. And I also have these transducers. In this case there are only 3 of them, but it will be sufficient for this demo. They are connected to the output of the power amplification module. So for real life it is of course not sufficient to have only 3 of them. For real life it should look like this. So I have 10 of them on the upper side, and I have 8 of them on the bottom side. So this is okay, but not the way like this. And we're gonna see how it works. So first let's start to see how the signal looks like on the oscilloscope. When I switch the device on, you will see that from the DigiSpark unit there's a pulse signal frequency that swings around 25 kHz, which is the center frequency of the ultrasonic transducers. But the swing is actually very random, so it swings 2 kHz lower and 2 kHz higher than the center frequency value, the 25 kHz, and that will give a white noise that is around from 1 kHz up to 6 kHz on the microphone input, and you're gonna see that in a moment. I have my smartphone with me, and what you can see right here on the screen is an application named Spectroid. It is only to show you the audio spectrum that is received over the microphone. So the microphone is from this side, and you can see my voice here. And now the scale is logarithmic, so it should be visible, the 25 kHz, when I switch this one on, and I will switch this one on, so you may be noticing some buzz noise. It starts in 2 seconds. You can see 25 kHz and the noise over here. So you have observed the noise over 25 kHz and as well on the lower frequency between 100 and 10 kHz. I will now switch the display to the linear, and then you can see whole frequency range. So it is now linear, and then when I switch the jammer, you will see the peak over 25 kHz. So it's now starting, takes 2 seconds. And now the real jamming test, I will count to 20 and you're gonna see when I'll be switching on and off how it works. So let's get started. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 15, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So I think it's sufficient. So you can see that it jumps pretty well, but I will now replay the voice. 1, 2, 3, 4, 5, 6, 7, 8. 14, 16, 15, 17, 18, 19, 20, 21, 26, 27. So I think it's sufficient. So okay, so you can see now how it works, and in real life, if you have something like 20 of these ultrasonic transducers mounted, the jamming range is, I think it's even up to 10 meters. So in closed areas like rooms, the jamming is very effective, because these ultrasonic waves, they can bounce from the walls, and that gives an awesome results. So that's all for now. I hope you enjoyed this little video, and if you like this project, if you like such projects like this, please leave a like and please subscribe my channel. Thank you very much, and bye bye.